Welcome to my presentation class. In this video, I will be discussing ocean exploration, the history and achievements so far, how we explore oceans today, the problems revolving around ocean exploration, why it is important, and asking you a thought-provoking question. So go ahead and sink into your chair and let's dive into ocean exploration. In 1868, Charles Wyville Thomson discovered sea life at 14,400 feet, shattering previous theories that the sea was lifeless below 1,800 feet. In 1977, hydrothermal vents were discovered, along with an ecosystem that survives without the energy of the sun, by a team led by Robert Ballard. These ecosystems rely on biota absorbing chemical energy from the venting materials in a process called chemosynthesis. This was a biological miracle, almost as miraculous if we were to make contact with aliens. In 1985, a research team led by Robert Ballard discovers the Titanic more than 12,500 feet down, the most famous shipwreck in modern history. In 1992, the Topex Poseidon satellite begins mapping the surface of the sea. In 1995, the first ever mapping of the seafloor begins, thanks to the declassification of the U.S. Navy's Geostat radar. In 2010, the first ever census of marine life catalogs the diversity, abundance, and distribution of marine species collected in an online database. In 2012, the first successful solo dive to the Mariana Trench is completed, telling us that the deepest spot on Earth sits at 36,201 feet deep, which is almost 7 miles. And most recently, in 2017, an international scientific team announced a plan that aims to map the entire floor of the oceans by 2030. 2030 may be close, however, the mapping of the entire seafloor is long overdue. This is a long, impressive line of ocean exploration's history. Some of those mentioned were monumental discoveries, such as hydrothermal vents and the Titanic. Let's watch and listen to National Geographic tell us about how our oceans are explored today.
There's definitely a better way of doing it that's a lot safer and less expensive.
Today, we've found a more time and cost-efficient way of studying the ocean using ROVs, remotely operated vehicles. Connected to a ship by a long cable, ROVs act as our eyes, and in some cases, our hands as well. And thanks to satellite technology, oceanographers no longer have to spend months at sea. From the ship control room to ocean research centers, or even home offices, scientists around the world can observe ROV discoveries on live video feeds.
For example, we have found some new hydrothermal vents, and the height of...
Ocean experts all over the world are more interconnected than ever before.
So despite the ease and cost-effectiveness of ROVs and satellites, there are still problems with ocean exploration. Currently, only 5% of our oceans have been completely explored, analyzed, and documented. This is the overarching problem, impacted by the following problems. To quote NOAA, the National Oceanic and Atmospheric Administration, exploring these regions deep below the ocean surface is difficult, time-consuming, and expensive. While this is a valid point, exploring the Moon and Mars can't be easy, timeless, nor cheap. There is more focus on space than the oceans, and because of that, there isn't enough government funding to explore at a more efficient pace. And lastly, another problem is our general knowledge of our oceans, rather, the lack thereof. Quoting NOAA once again, we are flying blind when it comes to management, regulation, and resource use in deepwater areas. If we don't know all the ins and outs of our oceans, are we really qualified to be managing and regulating it? So why is ocean exploration important? Well, according to NOAA, the only government agency concerned with ocean exploration, there are many reasons. Our oceans play a role in everything from the air we breathe to daily weather and climate patterns. 70% of our breathing air, oxygen, comes from our oceans, while only 28% is produced from our rainforests and the remaining 2% from that cute little tree I planted in my yard a year ago. It is a documentation of biological, chemical, physical, geological, and archaeological aspects of the ocean. Without this documentation, we will continue to be flying blind in regard to our oceans. Our oceans, which cover more than 70% of our planet, have a large impact on the environment, and through ocean exploration we can establish the baseline information needed to better understand environmental change. Ocean exploration can reveal new sources for medical drugs, food, energy resources, and other products. It can help predict earthquakes and tsunamis and help us understand how we are affecting and being affected by changes in Earth's environment. Lastly, ocean exploration can improve ocean literacy and inspire young people to seek careers in science, technology, engineering, and mathematics, creating a smarter and brighter future. After that information overflow, go ahead and ask yourself this thought-provoking question. Why have we spent more time, money, and resources on space exploration rather than our own oceans? Thank you for watching, and please enjoy this oceanic ASMR while peeking at the wonderful references that helped me bring you this information.